direction.
The first one is true or false. Okay. So from A to E, PM signal instantaneous frequency varies linearly with the derivative of modulating signal. So it's PM signal, okay? So that's false, because FM is doing it with that. So A is false. Signal B, signal can be demodulated by envelope detecting of the integral of FM signal. For FM. For FM, what we do the derivative, not the integral. So that one is false also. In commercial AM radio tuned using the super heterodyne receiver with intermediate frequency of 455 kilohertz, if you transmit 900 kilohertz, you may have image at 133.5. That's also
False.
false.
It's F. That's because it's FS plus or minus 2 times IF, right?
Yes, yes. I
116, son.
okay, I may have to do something here. Okay. In frequency division multiplexing, multiple signals are transmitted at different times and share the same channel. That's false also. The power of an angle modulated signal is equal P equal A square over 2. That's true. So now the second one, if you have a spectrum of sine of sinc of B square, so B1 sinc square of B pi B1 B1. What is this sign? Convolve. Yes. So now you multiply by, convolve with 2 into sinc of 2 pi into t. So if you look at that, the first one, so if this is convolved, what would be in the frequency domain? They're going to multiply. Okay, so if this is the situation, then you have the first one as is. So it's going to be F over E1, and then times rectangular of F over 2. So you see, these are the same thing that you see in your, so now, what would be the result? If B1 is 10 kilohertz, and B2 is 2 kilohertz, then you would see that one of them is going to be here, 2 kilohertz, and the other one would be, let me try to time this thing, 10 kilohertz. So it's going to be what we see here, if you multiply these two, and you will see and if you want to draw the other side, what it is. So plus 2 kilohertz minus 2 kilohertz. So it's one-sided, it's going to be about 2 kilohertz. So when you are multiplying the frequencies are not going to be added up. They are going to get if they are on top of each other, as we discussed before, it's going to be the lowest of the two. Then that is also another thing. We talked about Parseval, okay? Parseval. We wanted to see Parseval theorem to solve this. So we have 0 to infinity of 100 divided by pi squared s squared plus 25 to the power 2 df. Okay? So we want to use Parseval theorem. So what is the Parseval theorem? Is that you have a 2a divided by a squared plus 2 pi f squared. This one into what? E to the minus a absolute value of t. Yes? Some of you made mistakes. You went to some other thing. So what I have to find out is that if I put a k here and a k here, what would be the value of a and k? Okay? So if I do the value of a and k, what would be the value of a?
5.
So we have a pi f, so I have to multiply this by what? By 4. Yes? Because this is the way I'm writing it, is 10 divided, so we are going to have k2a divided by, what is a in this case?
5.
No, it's not 5, it's 10, because, so it's a squared plus 2 pi f squared is equal to 10 divided by, okay, now we have to multiply this by 2, so it's going to be, here we are multiplying by 4 because this is a square. So a is going to be 25 times 4 is 100 plus 2 pi f squared. It's going to be 2 pi f squared. Is that right? See, we had only pi f squared here. So in order to get 2 pi f squared, we have to multiply everything by 4. Okay? So I multiply this by 4, this by 4, this by 4. So everything is the same now. Yes? So now, you see here, what is this? So A would be what?
10.
A would be 10. So 4, so 2k times 10 is equal to what? 40. So what is k? K equal to? Yes? So now, we have to do this. So, okay, I'm gonna erase this part. So now K is equal to, so we have to have, so we have, so if you remember we had minus plus GF squared BF is equal to minus infinity to plus infinity, what?
The absolute value.
Absolute, no, let's say absolute value of G of t squared dt, yes? However, what do we have here? We have 0 here. But since this is this number, this function is even function, this part is half of the whole thing. No? So this is equal to minus infinity to plus infinity 100 pi fs squared plus 25 df times 1/2. Okay? So now I'm going to do this. What is going to be? It's going to be 1/2 of minus infinity to plus infinity e to the minus gt squared. What is gt? Is a k squared. K squared is what?
2e to the -10.
K is equal to 2, so it's gonna be 4. E to the minus what?
20.
20. 20t, absolute value of t dt. So now we can see, because this is that, we can say, okay, again, we have it from here and here. So this is also an even function, because when you change t to minus t, it's the same. So we can see that this is going to be twice as much, so it's gonna be minus infinity, plus infinity, of 1/2 is gonna go away, it's gonna be 4 e to the minus 2 t, 20t, I'm sorry. 20t dt. So it's gonna be 0 here. So what is the value of that? So the value of that is gonna be 4 divided by 20. Okay, from e to the minus 20t from 0 to infinity. That is also minus.
Is it 2 integrals?
What?
Is it 2 integrals or just 1?
One answer. Minus 20t. So if it had 20, so it's gonna be minus this value because it comes minus 20.
It should be 2 over 20, right?
What?
2 over 20?
What?
No, 4 over 20.
Because the 4 gets pulled out over there and it's,
Four.
it gets multiplied by half?
No, because this is minus to plus. So it's, this one already multiplied by, so if you want to use this, you have to say,
Oh, okay.
this is half of that, so already this half is going to go. So it's going to be, this is at 0, this is 1, at infinity is 0, so it's going to be
Negative
4 over 20. It's not going to be negative, it's going to be 1 over 5.
1 over 5.
Some of you made a mistake, but I some of it I know. So, any question on this? Any question? Okay, let me go through the next one. And I erase this.
Professor,
Yes.
why is e to the negative 20t?
Because already was e to the minus 80. A was what?
A is 10.
But it gets
It's
weird.
equal 10. But this one is a square.
Oh, okay. So it's square.
Okay? Any question anymore?
It's easier now.
What?
It seems easy now.
Yes, it is easy. Most of you didn't use that. You went and you
Yeah.
tried to solve this by itself. I told you to use Parseval theorem. And you had it in front of you, no? Yes? Okay, let's go back and do the next one. Okay, here, we had this here as array. Okay, and I give you all of the things that you wanted. So I said, okay, what is the value of, if I have FC, and FC I said is about 6 times this, so it's good here. The first one, this is A. DSP minus SC, and then if you go here, B, you wanna see what is here, so it's gonna be here, and here. Okay, this is B, but you have to add what?
Omega C.
Yes, so we have to add. Okay, okay, so this is B, so it's gonna be ESP minus SC, ESP plus S. And then we have US, if we have this, so what is the difference between this and that? It's going to be just half of that. So you're gonna have this. And so this is U. So USSP plus CU upper. The lower one without that is going to be what? Wait, this is FC.
Other side.
And the last one is going to be to have that, so last one would be the same thing as this, but you are adding the, this is the, I'm sorry, this one. This is a C. Okay. So a sketch frequency response of a, so we have a, here,
Those three are the same one?
They're all FC.
which one?
The ones to the right?
This one is U, upper, okay, is U. So it's, if you adding, you know, to FC, here you are taking away from FC. So this is this side, this one on the other side. So this is FC is bigger than the whole thing, so this part lower than FC.
Is that the DSB minus C?
Yeah, that's what I meant, the name of the,
SSB single side.
This is,
Surprise carrier.
The C, L.
so you see F here you see for U is higher than FC, for L is lower than FC. It's going to be closer to 0. Okay, you guys got it? Got it? Now S equal A plus MT cosine of 100 pi t. So what is F here? FC is equal 50. And then FM is 10 kilohertz. Okay, FC is 50, this is 100, so it's gonna be cosine of A times cosine, and so A is 12 and a half, so S equal 12.5 times plus 5 cosine of 20 pi t. Okay, times cosine of 100 pi t. So you see that you have a carrier, so the carrier is here, so you have if I want to draw this, this is 100, so if I have 50 here minus and 50 here, so you are going to have 40 and 60 and this 50. 50. So this would be 1.25 each for all of these, and for this would be 6.25. Okay, then we have a calculation of power. What is the power calculation, PC? Your carrier is what? Is
A squared over 2.
a square of 12 and a half divided by 2. So it's gonna be 156.25 and by 2, and 78.125, and then PS would be 25 divided by 2 and 12.5. Okay, so now we have 25 divided by 78.125 plus 12 and a half. So this is about 90, so it's gonna be about 25 divided by
It's gonna be a little bit more than 1/4, right?
no, it's not 12, I'm sorry, it's 12.5. 12.5 divided by that. So it's gonna be around,
Oh, oh.
a little bit higher than that, so it's gonna be point 0.13 something. So that's how much,
Oh, 12.5.
what?
12.5, I said. I didn't see the.
12.5 is the PS divided by PC plus PS. That's
Okay.
that's the
What was that, what was the equation for that?
efficiency. What?
What was the equation for efficiency, so it's the PC divided by what was the equation?
PC divided by PC plus P, no, not PC, PS divided by PC plus PS. Okay, the other one, you see that we have this, number 5, we have phi of P equal 5 cosine of omega CT plus 10 plus 10 times sine of 4 TT. So what we do is that in order to find what is the omega I, is going to be what T phi dt, I mean T of P dt. So what is P is here. So this one would be omega C plus 10 times 40, so sine of 40t, when you do the derivative of sine is what? 40
Cosine.
times cosine. So it's gonna be
Negative
40
400.
times 10 is 400 cosine of it. So that's the instantaneous frequency. And the last one, so here, it's going to be, you wanna get the modulator and the modulator. The modulator is here. So we have cosine of omega t, this is nt, then we go here and we do the synchronous, so we get here again cosine of omega ct, so we have here what it is, it's at
So fast.
cosine of omega ct square times mt. This is mt times cosine of ct. And then we go through this, and that would give you 1/2 of mt. low pass filter. So what you have here is that first here you get point, you have 5 cosine of 2 pi FM. FM is 10, so it's gonna be 20 pi t times cosine of 100 pi t. So you have to see this one is going to be what? It's gonna be 2.5 times cosine of
-5.
120 pi t plus cosine of 80 pi t. So it's gonna be at 40 and 60. And so you're gonna have one half of that. So if you go here, it's gonna be 40, 60, 40, 60. It's gonna be one half, one or 2.5. So everything will be 1.25. Then you go to the modulated signal. The modulated signal would be what? Cosine of omega ct, so it's gonna be mt times one half of mt times what? 1 plus cosine of 2 omega ct. So you are gonna get again one half of that, so it's gonna be 1. So you will see that you're gonna have 2.5 again times that. So and if okay, there is an A also here, which I didn't put here, so you can have plus A is 0, so don't worry about that. So the reason I put A is 0 because I don't want you to mix up with the other one. So here you are gonna have 1/2 of and so it's gonna be 1.25 times and 1/2. Okay, so it's gonna be here. If you look at it here, we're gonna have this 1/2 of this, so it's gonna be 1.25, 1.25, and then here, and you go here, it's gonna be half of that, 0.65. And then here also. This is 2x. And at the end it said what is the output. So filter output would be equal 2.5 cosine of 25. It's gonna be this. Okay. Okay, I'll talk to you guys later.
Recording in progress.
Okay, recording is.
All right.